position in the upper left plot. I'm Dr. Alexander Hayes, and I'm a planetary scientist here at Cornell University. My team and I study other bodies in our solar system, such as Saturn's largest moon, Titan, using the Cassini spacecraft, which has been orbiting Saturn for the past 10 years.
Titan is 10 times further from the sun than Earth. That means it's really cold there. Here in Ithaca, it's about -8 degrees Celsius right now. But on Titan, it's a cool -178 degrees Celsius. But even though Titan is so cold, scenes like this, of flowing waterfalls draining into rivers and standing bodies of liquid, are not uncommon in its polar regions. In fact, somewhere on Titan it's likely raining right now.
I'm Dr. Mike Malaska, and I work in the Planetary ICES group at the Jet Propulsion Laboratory. And this is one of the laboratories where we study the properties of icy moons like Saturn's moon Titan.
Hey Mike, how are you?
Hey Alex, good. How are you doing?
I got your email. I thought we should talk about the latest results.
Sure, we've gotten some really good measurements in the lab recently. Even though we're on opposite sides of the country, Alex and I are researching Titan together. Alex studies the surface, and I test different possibilities in our laboratory.
Titan is the only body in the solar system other than Earth that we know to support standing bodies of liquid. The difference is that here, the liquid we're seeing is made up of water, whereas on Titan, the liquid is instead hydrocarbon mixtures.
Hydrocarbons are molecules that are only made out of hydrogen and carbon. On Earth, hydrocarbons like methane and ethane are normally found as gases. But on Titan, it's so cold that these materials are found as liquids.
We can make a guess as to what the composition is of the hydrocarbon liquids in Titan's lakes, and then give that guess to Dr. Mike Malaska to test those different mixtures. I can study how the lakes on Titan work by simulating them here in the lab. So now I'm going to be adding liquid nitrogen to the bath to bring it down to the same temperature as the surface of Titan. So the cooling bath is now ready, and I'm going to turn this valve, and that'll let the methane go into the tube where it will condense and turn into liquid methane. The apparatus has a live video feed, and as we can see, the methane is condensing in the tube. So now we have made a tiny little methane lake, just like we see on Titan, but it's right here in our apparatus on Earth. And now we can study that and play with it a little bit more and observe how these Titan lakes behave, and we can share this information with Alex, and so he can look at his satellite data and see if he observes the same things. Science is all about collaboration, especially when you're studying something like Titan. We have to bring together a wide range of scientists with a variety of expertise, and only by combining our knowledge can we really try to understand what we're seeing in the data from the Cassini spacecraft.